Hello everyone, welcome to Skill Dev. Trey here, and in this lesson, we're going to implement a graph data structure. There are a few ways to implement a graph, but one of the most common is an adjacency list, so that's what we're going to use here. Our graph is going to have three methods, one to add a vertex or a node, another to connect these nodes through edges, so add an edge, and finally, one to remove a vertex. And when you remove a vertex, you should also remove the edges that were connected to it. And this is going to be the shape of our graph object. In the constructor, we pass a boolean true or false if the graph is undirected, and our adjacency list is going to be a hash table. When we add a vertex, we just pass in the value for that vertex. When we add an edge, we pass in the source and destination vertex. And when we remove a vertex, we just pass in the vertex that we want deleted. It's also worth noting that this graph is going to have unique values. So you can't have more than one vertex that has the same value. And here's a representation of our adjacency list. The keys are the individual nodes, and the array, their value, are the edges that they're connected. So for example, the node A is connected to these three nodes. A is connected to B, C, and D. We also see that B is connected to A and D, C is connected to A, D is connected to A, B, and E is just connected to D. So we represent this graph and its nodes and their connections simply using a hash table. We use the add vertex function to add a node to the graph. When you add a node, it will initially be unconnected. So let's see an example of that now. We're going to add the vertex Z. Now it's just a floating node in our graph that's not connected to any other items. You can also see that we added it to the adjacency list. We have the node Z and then an empty array signifying it's not connected. Now we want to connect this node with other nodes by calling the add edge function. So we're going to connect Z with C. And since our graph is undirected, we add the connection both to C and Z. So we have this edge between these two nodes. Now we're going to connect B and Z. We do the same again. Now we add this connection in our adjacency list. Then to remove a vertex, you pass in the value of the node. So we call remove vertex on C. We also have these edges for C where it was connected to A and Z. So we need to remove those. And that's the overall functionality of our graph. And now we're ready to implement our graph using an adjacency list. There won't be any changes needed to the constructor, so we'll move on to the add vertex method. What we do here is pass in the data that we want to store in the node, and then we add it to the hash table. The key is going to be the vertex data, and the value is going to be the array of edges. Initially, it's not going to be connected, so it will just be an empty array. So we say this.adjacency list for the vertex is just an empty array. And that's all we need to add a vertex to our adjacency list. Now we want to add edges or connections between nodes. To do this, we first just push the destination node to the source node's array. So for the adjacency list, we access the source value and push destination. And source is just the source node, and destination is just the destination node. We also know our graph can be directed or undirected, and if it's undirected, we also need to add the source node to the destination node's edges. So if undirected, in the adjacency list, we just need to push the source. And that's all you need to add an edge. And finally, we want to be able to remove a node. So what we do is pass in the value of the node that we want deleted. And then to remove it, we just delete it from the adjacency list hash table. but there could also be some edges still pointing to this vertex even though it doesn't exist. So we need to clean up all the outstanding edges. To do this, we iterate through our hash table, and we extract the keys. Then for each node, and the node is just the key of the hash table, we set its value in the adjacency list equal to a filtered version of the edges. So by this, I mean we're going to remove all the edges that correspond to the vertex that we got rid of. So V is the vertex edge that's connected to, and we keep it if it's not equal to the vertex that was passed in. So if this returns true, the value is not equal to the vertex, it's kept in the list. If the value is equal to the vertex, it is then removed. And that's it. That's all the functionality we need in our graph. Let's see it in action. So we're going to initialize a graph, add vertexes 0 through 6, and then create connections between these nodes. We'll log the graph, see what it looks like, and then remove vertex 3. And there it is, our adjacency list that represents a graph. Here are all the vertexes we added, and these are the edges we created between them. Then when we remove edge 3, we see that it removed it from the graph, as well as removed it from the array for all the nodes that had an edge to it. So to quickly summarize, when we add a node, we call this addVertex function, and it just initializes an empty array in our adjacency list. When we add an edge, we just push the destination node to that source node's array. And if it's undirected, meaning the graph can flow in either direction, we also need to push it to the destination node's array. And finally, to remove a node, we call the removeVertex function with its value, we delete it from the adjacency list, and then we delete all edges that are connected to it. And that's our graph implementation. Thanks everyone, and I'll see you in the next lesson.